Right, so for this function, we have a lot going on here. So it's already in simplified, or it's already been like factored out for you, so you don't have to do anything. Right, so then we'd find our domain restrictions. Right, so everything that has an x in the denominator gets the chance to be zero. So x squared is zero. So zero would be a domain restriction. X plus 2 could equal zero. So that means that x equals -2 would be a domain restriction, and x minus 3 could be zero. So that means that x is equals 3 could be a domain restriction. All right, so then that's it for domain restrictions. So now let's start to cancel anything we can. So here's an interesting thing that happens, right? So if I look at this x minus 3, it cancels with only one of those x minus 3s. So we could rewrite our function as x plus 1 squared, x minus 3, all over x squared times x plus 2. Right, so notice that my factor of x minus 3 in the denominator canceled completely out. Where it's gone from the denominator, whenever we lose a factor from the denominator, it ends up being a whole. So 3 something would be the x corner of our whole. The other two domain restrictions that did not cancel completely out, each of those ends up being our vertical asymptotes. So 0 and -2 would be our two vertical asymptotes. All right, so if we want to find the y coordinate of the whole, we're just going to plug 3 into the most simplified version, right? This one up here. So if we do that, we're going to get 4 squared, which is 16. 3 minus 3. Oh, stupid me. So yeah, it's going to be 0. Right, so 0 and blah, blah, blah. Doesn't even matter. Right, so 16 times 0 is going to be 0. So we're going to have a whole at 3, 0. So technically not an x-intercept, right? So I'm not going to write that as an x-intercept. We technically have a whole there, but we also do want to think about that when it comes to our table of signs. So our degree of the top, degree of the bottom, right? So in here in our simplified, we have 2 and 1. So we're going to get a 3 here in the top. We're going to get a 2 and a 1 there in terms of power, so 3 over 3. So this means that the degree of the top and the degree of the bottom are the same. So a horizontal asymptote is going to be the ratio of lead coefficients of the top and the bottom. Top and bottom. All right, so when I look at the top, and I have a 1x and a 1x. If I multiplied 1x and 1x, I'm going to end up with a lead coefficient of 1x to whatever power. Same thing here, I have a 1 and I have a 1. So my lead coefficient is also just going to be 1. 1 divided by 1 is going to be 1. So a horizontal asymptote is just going to be y is equal to 1. All right, so then x-intercepts occur whenever the numerator is equal to 0. So we would get a x plus 1 squared is equal to 0. So this means that x is equal to -1. And again, the be careful moment, the x minus 3 is equal to 0. But remember, x was a domain restriction, or sorry, 3 was a domain restriction. So -1, 0 is an actual x-intercept. 3, 0 we saw was a whole. Right, so just a very, very subtle point that we just want to remember. In terms of the y-intercepts, well, we don't have a y-intercept, right? Because if I have a vertical asymptote when x is equal to 0, I can't plug in x is equal to 0. Right? So there's going to be no y-intercept for this function. If you are robotic and you just plug in 0, just be careful about where the 0 ends up. I'd have 1, over here I'd have 1 squared times -3, which is -3. 0 times 2 over 0. -3 over 0 is undefined. It's not equal to 0. All right, so then let's create our table of signs. All right, so we care about x is equal to 0. Right here, x is equal to -2, right? That was our vertical asymptote. And also x is equal to 3. This was a dumb way of me writing it. So vertical asymptote here, vertical asymptote here, and again, technically a whole right there. But we could change from positive to negative on either side of those holes or that hole. So we just want to incorporate as well. So just like I did in the last video, if you're unsure and I kind of do this one too fast, just feel free to go back to the last video. For a table of signs, a reduced function is x plus 1 squared times x minus 3 all over x squared and x plus 2. So we can always look to simplify our table of signs a bit. So if I have x plus 1 squared, anytime I square a non-negative number, let me try that again. Anytime I square a negative number, it's going to be a positive number. Anytime I square a positive number, it's going to be a positive number. So this x plus 1 squared is always going to be a positive. By that same logic, whenever I square a negative number, I'm going to get a positive. When I square a positive, I get a positive. So that x squared is also going to be a positive. I have a positive and a positive, right? So those things just stay positive. So in terms of our table of signs, not for our function, we really can just look at the function x minus 3 times x plus 2, because while I'm multiplying x minus 3 by a positive and x plus 2 by a positive, so those positives don't affect anything. And so if we then look at some number less than negative 2, so if I plug in, say, negative 3, so negative 3 is going to give us, negative 3 is going to give us a negative number on top, a negative number on the bottom. Negative over negative is going to be a positive value. If I plug in anything between negative 2 and 0, like negative 1, right, so when I plug in that, I'm going to get a negative number in the top. I'm going to get a positive number in the bottom. Right, so that's going to be a negative number. If I plug in anything between 0 and 3, like just regular old 1, I'm going to get a 1 minus 3, which is negative, a 1 plus 2, which is positive. So negative over a positive is going to give us negative. And if we plug in anything greater than 3, like 4 or 7,306, we're going to end up with a positive number over a positive number, which is going to be a positive number. So if we want to analyze where the function is less than 0, again, we want to be careful about our domain restrictions. It's less than 0 between negative 2 and 0, union 0 and 3. Right, so again, this is not negative 2 to 3 because 0 is not part of our domain. And then finally, we want to know where it's positive from negative infinity to negative 2, and then again from 3 to 0. Right, so that would be our domain restriction. All right, so that is that's our answer. That's our values. So last one.